Hi guys, today I'm working on a random A star move component in FXGL, and I'd like to complete this today. So essentially my idea is that you can drop a component to an entity in a A star environment, which is like a grid, and it just moves inside that grid whilst avoiding obstacles, which is quite sort of common behavior in NPCs and other enemy things in various games. So it's quite useful. Right, so what I need is to have some kind of a level going. Let's create an object layer and start adding some things. Type is going to be just a wall. There's going to be a wall here. It moved over here. Yeah, that should do it. That'll do. Maybe just one more. So we've got some obstacles going. We just need to parse this thing into FXGL now. Right, so the file should be here somewhere, random A star. Yep, it's all done. So let me just make sure that it's built. How do I rebuild, just in case? Because IntelliJ sometimes forgets copying resources into the target directory. I don't know if it's a bug or something that I need to just turn on. One of the features in FXGL, sorry, in IntelliJ. Pathfinding, no, we don't need that. Cell width 40, that isn't correct anymore. So I've got a sample going, which is copy pasted from just pathfinding, normal pathfinding. And I want to just modify it slightly so that we have a level. Right, we don't need any of these because we do actually have a level, and for that we need a factory, because there's only one type of object that we have at the moment, which is wall. Wall factory. I'm going to annotate it. So it spawns the wall that we need. Entity. View with bounding box. New rectangle. We need to obtain width and height. I think they're doubles, right? Yeah. Let's make them red. We probably need some kind of type thing going, because I want to parse this automatically into an A star grid, and we have a function for that. But to work, it needs to know the type. It's called type wall. There we go, that'll do. Is there anything else I need to do? Okay, let's run this and see if we can parse it correctly. We need to add the factory, of course. Let's keep forgetting that. We're not even loading the level. That's okay. Get game world, set factory, add factory. That's done, and now we need to set the level from a map, which is under levels, so TMX. Okay, let's try that. Integer cannot be cast to. Why is it an integer? It was double in the tiled application. Okay, I think that's it. Yeah, that is it. So we got our obstacles in the level, and what I would like my NPC, so-called NPC, to do is just go around these randomly and just wander around the level. And then it becomes a very reusable component that people can just add in their games by just attaching them to one of the entities that they have. So this grid doesn't get generated, it has to be built, because it needs to take into account all the information from this level. A star grid from world. This is the world that we're passing in. Takes world width, world height in cell units, and then cell width and height in pixels. So in cell units, it's 20. Oh yeah, I can just use these. And then a mapping into walkable. Okay. Type return. If type equals wall, then it's not walkable. Else it is walkable. Okay, so we built the grid from our world. Don't need that. Not the Pathfinder thing. Now this should generate the grid. Then I need an entity. This is where this thing comes in. Cell move component. Yep, that's the speed with new A star move component, so it knows how to move around the obstacles. In which case we don't need the Pathfinder thing, right? And then finally, this new component, which is still being built. I'll just add it for now. Random A star move component. And then the idea is that people can just add this component to their existing entity, and I'll just start walking around the level. Yeah, let's position the entity in one cells already, and then everything else just goes. Doesn't do anything on update, so nothing should happen, but we should see an entity represented by a rectangle. Cannot inject A star move into A star. module. That's interesting. That we do open this module to all. So this is the error. This is the thing that's causing the issue. Injection of that into this, which should just happen automatically. But for some reason, it's saying the module doesn't allow it to do so. Interesting. So where's module for this one? Java. Oh, I don't think I've ever opened that package components to the core. So this should happen. Open DSL components. Should work now. Okay, so we've got our entity and it has all the things, but it has no logic. And this is the interesting bit. This is where we get to implement some of the moving logic. I already have some bits and pieces from different game samples that I implemented. They all had only parts of the logic. What I want to do is very sort of flexible, generalizable component that people don't need to change. And they can just add it by providing some values. So this is the thing that we need to use in order to create minimum distance between current cell and future cell, the next cell, maximum distance. Yeah, let's implement the simplest thing we can do, which is if move timer elapsed delay, then move and recapture time. Right, so that was simple. What about actually moving it? We only want to move again. Actually, there is another to do here. Can we move while we're still moving? Is that even a valid question? What I mean is, because we can reach the destination and then move, or whilst moving to that destination cell, can this move timer trigger another move to a different cell, in which case we just forget about the first movement. I think this could just be a simple Boolean, but I'll add it later. For now, I just want to focus on the simplest thing, which is if A star is at destination, that means we've stopped moving. And this is how I get the cells. Okay, A star grid. Walkable cells and then filter, I guess. Filter based on this predicate. it. So we filtered it, filtered the list, and then find just pick any. Actually, I don't think we even need this because we can just continue the call. Can I just do let on this thing? I suppose we could do it this way. And this is the cell that we obtain. So provided we find a non-null cell that can be filtered with this predicate, and it's walkable because we're only checking against walkable cells, then make the entity move to that cell. A star move to cell. And then we're going to introduce these minimum and maximum distance. For now, I just wanted to move. And then once we've moved, capture timer. Again, we need to figure out where to move this thing because we want to, do we want to capture timer after the move, or do we want to capture timer after we've reached the destination? Okay, it's moving now. It's good. But I'm not sure why it's taking so long. So if it is at destination and move, just add print out move, have the timer somewhere here. Oh, right, it's always picking the first cell. We need to somehow randomize this. So there's this get random cell. Okay, let's try that. Get random cell using this predicate, which tells us that a cell is walkable, because if it's not walkable, there's no point in selecting that. And this thing passes. And then if such a cell is present, then move to that cell. Okay, now we're getting somewhere. So we have a random NPC now. That's good. We can probably add more to make this a bit more interesting. But I suppose before we do that, we need to fix these things. Right, so this is no longer needed. right? Yeah. This is quite interesting. Checking minimum and maximum delay and adding a random sort of aspect to it. I guess I could add another to do here. Randomize delay based on min max values. Add boolean to allow moving even if didn't reach destination. I quite like this predicate here because we can easily add this thing as well, right? We can see where we are and then check how many cells we can move. Current cell. Is there a current cell method here? There's got to be one, at least in cell move, because it needs to know where it is in order to move. So I can get cell X and Y, but I can't get the cell itself. That's odd. I need to add this API in. So that's very useful to know where we are. Oh, fair enough. Cell move component can be used even if you don't have a cell, as in if you don't even have a grid, which is fine. And I remember adding this in to make it more general, so you don't have to be fixed to a specific grid. The cell move component is actually an abstraction over just movement. It just allows you to move in cell type formation. Okay, then a star movement should be able to give me what the cell is. And that's something that I can add, but not in this commit. I don't like adding a bunch of stuff in one commit, particularly if they're not related. So add current cell or something. Current cell function to a star. But given that we now know X and Y, it shouldn't be that difficult. Cell X. And then the cell is a star grid get X and Y, which should give us the cell. Yep, perfect. Now here's a question. Can we ever go out of bounds? Because we're moving using a star, right? I suppose we could do something like that. If a star grid is within cell X, cell Y, however, if it isn't within, then we have nothing to do because we're not even within the grid. So what's the point? Just return. In which case, this is now valid code, as in it won't crash. This is generally the tricky bit when it comes to crashing, not crashing. Like if you're building a library, you really want to make sure you've covered all possible edge cases, because you never know how your users are going to be depending on that library, because they might want to have a different context or different use case. So I got this cell, and this is our current cell. Using that, we can also test and current cell distance to this cell is greater or equal to min distance, and it's less than or equal to max distance. Provided this works, I should be able to limit the movements of this thing. Let's speed it up. So this is the speed, and the order is minimum and maximum. Okay, so minimum, I want it to move at least one cell, that a maximum of 4 cells. And then if this works for one entity, I'm going to add more. Cool. So it's moving in short bursts. It can't move further than 4 cells from its current cell though. So it can reach at some point the entire map, but in one go it will only move a very short distance. Yep, not bad. Let's add a bunch more entities. Spawn NPC, and then we provide the cell coordinates. And then all of that just goes in here. This becomes X and Y. And let's give each NPC a different color. 1, 1. Maybe something like, need to look at the level. Somewhere 7, 17. 1, 11. And then let's add one more somewhere here, which is 18.5. There we go. So we should have 4 entities with each with its own random color, just moving around the level in very short distances, because they're all limited by 4 cells. And this is where random delay would come in really handy, right? Because currently you can almost like see the pattern. They move virtually in sync. They stop and then move, stop and then move. But if we randomize the delay between movements, then the movement itself will become a little bit more interesting, less robotic, I suppose. So this is a minimum delay. And I guess if they're the same thing, that means that's the time to use, the delay to use. Whereas if they're different, then we can make use of that. Next delay, or just delay. And it's a random value in seconds between max and min. Duration seconds, random between min delay in seconds. I wonder if I should take parameters as just doubles in seconds. But this duration object is much easier to create and kind of think about. But I suppose it kind of separates distances from these two. Because if you're looking at the call site, and when you're designing API, you should always look at the call site, then just seeing a bunch of numbers doesn't really help. Like, what is 41433? Whereas with duration, it's really easy. You actually see what it is. Duration seconds 1, and then duration seconds 3. So it's going to wait between 1 and 3 seconds. And then this needs to be recalculated every time. So this is the delay that we wait. And then when we right, so once we capture, then we also recalculate. So that's the easy part. But when do we capture time? That's the question. If as a destination, so if we're a destination, then we move. Once we move, we're going to at some point reach the destination. Once we've reached the destination, it is then that we capture time. Because according to documentation, which I just wrote recently, it says delay between us stopping and then moving again. So it's not between we started moving and then we can start move again. It's between us stopping and then moving. So stopping means this thing, if we're at destination. So it should be here somewhere. We stopped, we captured time, we reset the delay, and then when the delay elapses, then we move. So this is actually not here. This is supposed to be here somewhere. And that's outside of it, because otherwise it will never reach that. So this will only trigger when we have reached our destination. Then we recaptured our delay in time. That means this will never be called before this. So we have to wait. Then once this is over, the delay is over, we check if we can move, and then we move. And then this will only get to that point once we're at destination. But we don't want to trigger this thing because that will keep returning true. Which means it will keep yeah, we need an extra check in here somewhere. Like this thing, I feel should be even outside of this if. Like if we haven't reached destination, then just return. Don't do anything. If we're moving, and then I'll handle the edge case where we want it to move separately. How about that? In which case, if we're at destination, just not at destination, just stop. Then it becomes easier because we now know how to move, or rather when to move. When this thing is elapsed, start moving. And then capture time. How about that? Yeah, let's try this. Interesting. If not at destination. Does that mean they're never reaching their destination? Let's try that one, because that will override that one anyway. Right, so it gets here and then delay gets recalculated. Yeah, I see why this doesn't work. I think that's working, but I need to make sure it works in my head because I've just copy pasted this without really thinking about it into this if statement rather than outside of it. I'm actually still processing how it works. So we got that's just noise. If we're not at destination. Stop. Okay. If we stopped moving, then check if the delay has elapsed. If yes, start moving, and then capture time when we started moving. And then this will prevent, because we're now moving in the moving state, this will prevent us from getting into this code until we reach the destination. No, this doesn't work the way I want it to work. I don't think. Because this thing still captures time when we started moving. And I think I've just remembered there's a listener that I can use here on added. Let's add another listener to this thing. A star add destination property or something. Oh, move component has its own add destination property. Okay. Just need to make sure that it fires when it finishes the entire move, not just in between cell moves. Add destination property, add listener. No, it's not that one. So it should print done when it has reached its destination, whatever that means. Yeah, that's the thing I was concerned about, because that means it reaches destination every time it moves to the next cell. Which means there's another nice listener that I could add into this thing, which is add destination listener to a star. And from then on, we'll know when a star has finished moving from one cell to another. I suppose a sort of naive approach would be was at destination, which is true from the start. And then here is at destination. And we reset, and in between we can check. We can check that we have moved from false to true. If not was at destination and is at destination, then capture time, because that means we've just now in this frame reached our destination. And once this thing is implemented inside a star, this will just become super simple. I'll be able to do something like this. So this at destination needs some documentation around it. Because destination cell, like what do you understand by destination cell? Apparently for cell move, it's every single cell is at destination. So once you've stopped moving, you're at destination, which is fine because that's useful information, but just not as useful in this particular use case. Was a destination, is a destination, let's reset. And then if we're not at destination, then return. If we are, and the timer has elapsed, start moving, which will render this thing to become false. So this code is never executed until we reach our destination. Once we have reached, we do this. Yeah, I think this now works the way I documented it. It's useful to document things before you actually implement them, because you have specification to work against. So it moves, stops, then starts delay time, and then moves again. And this is easily, well, somewhat easily testable if I set it to 5 seconds. And my minimum distance is always actually I can set it here. So let's keep this. This is 5, this is 5. Minimum, maximum is 1. So it should move deterministically one cell and then wait for 5 seconds. One, 2, 3, 4, 5. Yep, that works the way it's supposed to work now. Yep, liking that. Now we can start experimenting with others. And then we can introduce some randomness between 1 and 7, between 1 and 3. And these are just, software generated shapes. Once we, in some kind of game, add actual textures, animation, sprite sheet, it's going to look nice. Like I'm thinking Zephyria could really benefit from this one for enemies and NPCs. So they're not just static, they move around. And the main thing you want to do is break this synchronicity or synchronization between your entities, NPCs, AI agents, so that they don't seem like robots. Yeah, I'm happy with this for now. And then I've got 4 more things to implement at some point. I can get rid of all this now. That's nice to clean up your code base. I think this documentation is correct. All right, let's see what we've changed. First of all, we've added this, so that's an important thing. Open components to FXGL core. Basically allows injection into core components. That's interesting. It seems I've never. Okay. Wasn't supposed to do that, but yeah, I've added the entire thing because I forgot this thing lives inside there as well. Well, fair enough. I don't want to change the commit now. And then just push. could just add the other one in there. So samples, source, main, sandbox, AI. Let's just see. Should be all right. Pathfinding. So this will add this thing, and then we also need to add the assets. Yeah. Added random a star move component. So I'll add the text message in this commit rather than the previous one. Okay, all done. Right, so I've managed to implement random a star move component, and it needs a bit of tweaking once the other to-dos are finished. And see if you can use that in your own games. Thanks for watching.